Located on the southern end of Lake Powell, Glen Canyon Dam in Arizona is a Bureau of Reclamation hydropower dam that channels the incredible force of rushing water to spin turbines attached to generators that produce electricity without any carbon emissions. The water is then released back into the Colorado River. One of the traits of fast-moving water is the phenomenon of eddies, where water currents circle around an obstacle, such as a rock or a pylon, and then pushes back upstream against the current of the river. When dams release water, the high speed and whitewater nature of the emerging water can create eddies that circle back and put damaging pressure on the spinning turbines inside the dam. To prevent eddies, dam builders designed a flat, concrete structure called a tailrace or apron. A tailrace is placed at the bottom of a dam and delays the creation of possible eddies by extending the exit path of the emerging water. In 1965, dam operators allowed a high-flow release of water through 4 of the hydropower production units and 3 of the bypass tubes in order to send a large volume of water down the river from Lake Powell to Lake Mead. The force of that water caused the concrete to break in some of the areas of the tailrace. Several of the concrete pieces ended up near the base of the dam in areas that limited the effectiveness of the hydropower units that sent water over those areas. Over the years, the forces of water continued to slowly move those broken slabs around and gradually increase the inefficiency of the tailrace. So, in March 2021, Reclamation dam operators at Glen Canyon Dam decided it was time to repair some of that broken tailrace. One of the broken concrete pieces was more of an obstacle than the other pieces, and reclamation engineers realized that if they could lift and move that specific slab of concrete, they could reuse it to fill one of the larger gaps that were created when the original tailrace was broken in 1965. This would remove an interfering concrete slab, as well as create a flatter surface for the exiting water to cross, which would improve the productivity of both the tailrace and those hydropower units. The challenge was that this particular slab of concrete was estimated to weigh 45,000 pounds. That's about as heavy as 23 small cars. So how do they lift and move such a heavy chunk of concrete underwater? After reducing power production and water releases to just a few hydropower units, Reclamation scuba divers dove down and installed metal rings into the top surface of the broken concrete slab that they had previously selected. To the rings, they attached deflated balloons, specifically designed to lift heavy objects underwater. The divers then filled the balloons with air, causing the buoyancy of the balloons to overcome the weight of the slab, lifting it off the river bottom, just high enough to clear the other rocks and concrete slabs in the area. Once the slab was lifted, the scuba divers were able to simply push and guide it through the water to the identified location, and then guide it into its new resting place and deflate the balloons. These efforts improved the flow of water out of the dam gates and increased the productivity of those hydropower units again. The ingenuity of these dam operators and maintainers allowed this work to be completed while still meeting the power production and water delivery requirements of the dam. This is just one of the many ways the Bureau of Reclamation uses critical thinking, creativity, and problem solving to maintain and improve the facilities we use to conserve and manage limited water resources, while also producing clean energy for communities in the mountains and deserts of the Southwest.